Welcome to aminacademy.com. In physics, let us discuss about gravitational potential energy due to gravity, some solving problem. Look at these examples. An unknown planet orbits the sun with distance twice the semi-major axis distance of its orbit. If the Earth's time period is T1, what is the time period of its unknown planet? Here the given things are time period of Earth is T1 and you have to find the time periods of the planet you have to find. For that you have to use the given things first. The Earth's time period is T1. Semi-major axis of the Earth is A1. Means here actually the orbit is elliptical. So we are having major axis, half of the major axis is A1 let. Time period of unknown planet is T2. We have to keep it. Time period of unknown planet is T2. Semi-major axis of unknown planet is 2A1. Means it's given the unknown planet orbits sun with the distance twice the semi-major axis of the Earth's orbit. So the Earth's that unknown planet's orbit is semi-major axis 2A1 because 2 times more than the semi-major axis of the Earth. By Kepler's third law, T square proportional to A cube. That is, we can say T1 square is proportional to A1 cube, T2 square proportional to A1 cube. That is 2A1 whole cube. Here, T1 square over T2 square equal A1 square by 2A1 whole A cube over 2A whole cube, that is, which is because it's a 2 times more, that square cube of 2 is 8. So we can cut A1 cube and A1 cube. So we have 1 over 8. Therefore, the ratio of the square of the time periods is equal to 1 over 8. By cross multiplying, 8 T1 square equal T2 square. From that, we can find T2 is taking the square root of this side. 8 square root is 2 root 2 and T1. Therefore, time period of the planet T2 is 2 root 2 times the time period of Earth, that is T1. Next question. Two bodies of mass m and 4m are placed at a distance r. Calculate the gravitational potential at a point on the line joining them where the gravitational field is 0. Here we keep two masses m and 4m with distance r distance. Then let it be, we have to calculate the gravitational potential at a point. Here the point is here. At a point the m1 is x distance. At this point, particular point, this 4m is r minus x distance. Therefore, gravitational force due to m is gm by x square. Gravitational constant into mass of the first object divided by the distance square. Gravitational force due to 4m is g into 4m over r minus x whole square. Therefore, gravitational potential field is 0 at a point, the given point here. Therefore, both gravitational forces equal. Means here gm by x square equal 4g into 4m over r minus x whole square, which is equal, all cut, the equal parts are cut, then 1 over x square equal to 4 over r minus x square. Therefore, taking square root, 1 over x, that is 1 over x square root is 1 over x by 2 over r minus x, square root of this. Therefore, let's take the relation r minus x is 2x. By cross multiplying, 2x equal r minus x is 2x. Therefore, x go other side is 3x. 3x equal to r. Therefore, x equal to r over 3. X equal to r over 3. Then this second distance is r minus r over 3 is 2r over 3. Now, therefore, gravitational potential is minus gm over r over 3 equal minus 4 g into 4m over 2r minus 2r over 3. Then 3 3 cut, then take LCM both side, then simplifying we'll get 9 gm over r. Therefore gravitational potential at the point here is that net gravitational potential is minus 9 gm over r. Next question. If the masses and mutual distance between the two objects are doubled, what is the change in the gravitational force between them? That means mass of two point masses are doubled as if two masses and mutual distance between them are doubled. That masses become doubled as well as distance between them become double. What is the gravitational force after that? Here F1 equal G m1 m2 over r squared, where is universal gravitational constant is G, mass m1 and m2 over r squared. Now the masses and distance between two objects is doubled. That means G 2m1 instead of doubling the 2m1 to m2 over 2r whole square. So after simplification, 2 into 2, 4 and G m1 m2, then 2r whole squared is 4r squared, 4 cut, then it becomes both equal here. F2 is also we are getting Gm1 m2 over r squared. Here also Gm1 m2 over r squared. That is F2 equal to F1. The force, therefore, no change in gravitational force when masses and distance are double. Here, next question. If the ratio of the orbital distance of two planets d1 by d2 equal to 2, what is the ratio of the gravitational field experienced by these two planets? Here, the ratio of the distance are given, that is ratio of the orbital distance is d1 by d2 is 2 given. Ratio of the gravitational field distance of two planets is, let it be E1 over E2. Now, E equal to Gm by x square. Distance between them is x, that is x square of that one. E1 is Gm by d1 square. E2, because x equal to d, you can put it here, x equal to d2, then E2 is Gm by d2 square. Here, the given thing is if the ratio of the orbital distance of two planets d1 by d2 is 2. Here, E1 by E2 equal Gm by d1 square divided by, that is reciprocal multiplication, that is d2 square by Gm. Gm and Gm cut, that is d2 by d1 whole square. Now, from here, d2 by d1 is square root of E1 by E2. Therefore, d2 by d1 is here the d1 by d2 from this relation will get 2, but the given thing is d2 by d1 is half, because d1 by d2 is 2, therefore d2 by d1 is half. Here, therefore E1 over E2 is d2 by d1 whole square, that is 1 by 2 whole square, which is equal 1 by 4. Therefore E1 by E2 equal 1 by 4. From that we can get it E2 equal to 4 E1. Means gravitational potential one is 4 times the other. The moon Io orbits Jupiter once in 1.769 days. That is time period is given. The orbital radius of the moon low is this much. There's 4,21,700 kilometer. Calculate the mass of the Jupiter. Here the time period of moon is on I0 or low equal 1.769 days. That is here we have to convert in seconds. That is 1.769 into 24 hours into 60 minutes into 60 seconds. The orbital radius of the moon is given 4.217 into 10 raised to 8 meter. Which is given that is 421,700 kilometer is converted to this meter is 4.217 into 10 power 8 meter. Therefore, we know the formula m is 4 pi square r cube by gt square. By using Kepler's law, we found this formula m equal to 4 pi square r cube by gt square. Kepler's formula as well as universal gravitational constant g, that is we are applying the values 4 pi square 3.14 into 3.14, r is 4.17 into 10 power 8 whole power 3, which is equal divided by g is gravitational constant is 6.67 into 10 raised to minus 11 into t is 1.769 into 24 into 60 into 60 whole square, yeah, which is m is equal 1.898 power 24 kg. This is the mass of the Jupiter. We have done. Please subscribe our YouTube channel.